Greetings, my name is Phil Willoughby and this video is about a PC case that I designed and built. It sits on my desk behind the monitor. The monitor is actually mounted to the case. In concept, I guess that's quite similar to an iMac or other all-in-one systems that you might be familiar with, but the difference in this case, no, sorry about the pun there, the difference in my case is that it has a full-size motherboard, it has a full-size graphics card, all of the components are real. I even managed to fit a massive radiator and water cooling loop in there, and it doesn't occupy any more desk space than a all-in-one traditional system would. So instead of having low-power laptop parts in my PC, I have a Threadripper, I have 64 gigs of memory that's overclocked, I have a 3090 on water cooling, so many NVMe drives, and because I've got all those PCI Express lanes and so many USB ports, all of which are useful to me. I built it to see if it could be done, and the answer is yes. The system that I've built is very much an ugly prototype. It works sufficiently well for me, but my motivation with this video is to show other case manufacturers, like real ones, that it can be done, that it might be a useful thing for people to have, and like my ideal outcome is that at least one of those real case design companies decides to do it, and then when I come to upgrade my system in a couple of years' time, I can buy an off-the-shelf case that works like this and build my next system inside of that. This is what it looks like to me as I'm sat down. So I want to point out some things I think are relatively important. I'm using these light bars here to illuminate the wall behind, and which helps manipulate the contrast ratio of the screen as I perceive it. I've got RGB strip on the back of the monitor here, which is illuminating this white front panel. I find without that, the area underneath the monitor appears really dark, and that again affects the perceived contrast ratio of the screen in a negative way. I found that having this illumination materially helps me when I'm having a long day at the desk. It helps me feel a little less fatigued. As you can see from this is a pretty true representation of my vantage point when I'm sat down. As you can see, I can't see very much of the case other than this front panel and these supporting legs which stick out a little bit here. I'll show you a wide view in a moment, but this is a true representation of what it looks like. So on the front I've got obviously the power button, headphone socket, with a physical switch to choose whether I'm on headphones or not. I've got front panel mic or line in, again another physical switch to make a deliberate choice. I chose to make them 1/4 inch jacks rather than the 1/8 inch size because I do a lot of music audio work, and that's the standard connector size in audio. If front panels came with XLR and balanced inputs, I'd have used that instead. Here we have 2 USB-C front panels, because the motherboard I bought has 2 USB-C front panel connectors. Other than that, there's not much you can see here, so let's zoom out. Right, so I've got as you can see, a wall mount for my headphones, many of which removed a big mess on my desk to the left and the right, which is more normal for what my desk looks like. I just want to give you a measurement of the depth of the table. So that's 25 inches or 633 millimeters. So not very deep, and as you can see, I can fit a GN keyboard mouse desk mat thing and the case on the table, no problem. These supporting legs are actually not required when the case is fully populated and the water loop's full of water, that there's enough weight there to counterbalance the monitor, but I feel happier with them, and they're not in my way. That's a space mouse which I use for CAD, which is the primary purpose of this computer, or at least the reason its spec is so fancy, which we'll get onto in a moment. Yeah, so the idea here was I want a computer on my desk that's got a lot of cores, a lot of memory, a lot of graphics processing power, and takes up no space. So although it looks like there's more space on this desk, to have a separate computer, I could put one here. Normally there's a Mac Mini there doing audio stuff and Final Cut, and although it looks like there's loads of space over here, historically there was my work computer's monitor, which ended about here. So I had no desk space to play with once I put those things in, or at least no space to put a case that's commercially available and that can fit a Threadripper CPU and a 3090, which is what's in the machine. Let me also, one last thing while it's still fully assembled I want to show you is this is the original stand for the monitor. I'm going to put it on top of the case. So I can show you that the case I've built sticks out about as far as the original monitor stand does, or slightly less. So compared to the situation of having a separate PC case and then that monitor stand, I've effectively got my PC case for free in the space, because it's occupying no more of my desk than the original monitor stand would have done. Now, admittedly, that LG monitor stand is particularly chonky compared to the ones from Dell, for example, but it was the perfect panel, or the best panel for my needs at the time. We'll now do a brief tour of the sides. So this is, on the left side, I've just got 3 outlet fans. You can see the water reservoir through there. And then this is an access panel with fuzzies in it, so you can plug in external peripherals. So that's where the Space Mouse cable goes through. And then on the right-hand side, we've got the standard power supply, bunch of USB ports, and 10 gig networking, and another fuzzy for any other connectors that I prefer to have on this side. Normally I would have a lot more stuff plugged in. All of these are usually populated, and there's 5 or 6 cables on the other side, but we're packing up to move house, so it's a lot sparser. And then on the top here we've got a 560 radiator, so that's 4 140s, and it's cross flow, so the water comes in here and drains out there. And we've got the Bluetooth antenna. So I think that's everything I want to. Well, that's not everything I want to say about it in situ. So a couple of things. It was an important design point for me to get the I/O and the power cable as low to the ground as possible, because I think that makes tidying the cabling on my desk easier. So that's why these fuzzies and stuff are at the bottom of the thing. Normally, so this is the display port that comes out of the high front panel behind the screen and then into the back of the screen. This is the monitor's power cable, which I could route inside the case through that hole and out the back again if I wanted to. These are for the upper deck lighting. Again, I could, and have in the past, routed them more neatly. It's just slightly disarrayed at the moment. I also should the original design I wanted to do would have been 3 140s on this side pushing in with filtering, and I'd have had another 2 on this side with filtering pushing in, and then I'd have liked the top to be an outflow with no fans on it, because I find the fans restrict. Sorry, the fans restrict how much access to the radiator the air gets, and I was hoping to make a very high positive pressure inside, and then that would force air through the radiator upwards, and see if that worked. Kind of a similar principle to the Corsair 1 case, except in reverse. Unfortunately, I designed this based on the dimensions of a 2080 Super graphics card, and then when the 3090s came out, they were much bigger. So the case has no back panel on it at all, because it wouldn't physically fit. Anyway, that's it for this B-roll. I will dismember it and show you what's inside. So this is the computer case with the monitor removed. So you can see there's a hole. Out of there comes your display port, USB-C for the top camera, and this is the RGB control for the RGB on the back of the monitor. And then the mount is a really cheapish, low profile Visa mount that's intended to be on a wall, and then I've replaced the wall screws with the correct fixings to anchor into the case. And so I didn't engineer it so that it can be adjusted up and down. I set up the monitor on its own stand, got it to exactly the right height and orientation that I wanted, measured where that was, and then recreated, the center of the monitor is the center of the mount in the case of the monitor I've got, so it's pretty easy to recreate the height, and then I can adjust the angle from with it mounted. It just requires tools. And as you can see, all the panels other than the front panel are made from just scrap acrylic, because this is a prototype. I didn't want to spend serious money. This is some POM, acetal, Delrin are the other names for it, that I had lying around, and I could get a really sweet diagonal machining pattern on it, because my CNC wasn't perfectly trammed. And I quite like it. It makes it, it shows how it was made, which is something I like to do. Okay, this is the internals of my PC. As I've been using it, I haven't even cleaned the dust off the GPU. Let me talk you through how the water cooling is set up. So you've got reservoir, pump. This little ring here is a temperature sensor for the water temperature. Water runs into the CPU block. That also cools the VRM. There's a maze in there. Then it comes out into the GPU, out of the GPU, into cross-flow 560 radiator, and out back into the reservoir. So you're getting an idea of the internal scale here, that there's so much space. If I wanted to have, a rack of hard drives, I could easily use all 8 ports of my motherboard and just fit them in here on some kind of mounting system if I wanted to do that. The water loop, the fan speed of these fans, and indeed the exhaust ones, is all done. The curve is based on the water temperature. So I rigged up, when I first got the system, I had loads more temperature probes in there, like outside air temperature, which was out here somewhere, inside off the radiator temperature at the hottest end, and then probes around here and various other places. And what I found was that unsurprisingly, the only number that really very directly affected by increasing or decreasing the fan speed is the water temperature. because the more airflow past the radiator, the more heat exchange from the water to that air that you've got the chance to have. So I then did the work to find out, what water temperature means that this cooler here is efficient enough and this cooler here is efficient enough to keep the CPU and GPU at maximum efficiency all the time, and then tuned a fan speed that I could live with. I don't hate the noise level of it in any way, so just find something within my tolerance zone, and happily that fan speed I can live with keeps the water much cooler than is necessary to keep the CPU and GPU in the right zone. So there is a fan curve set if the water rises above that temperature where the CPU and GPU start having problems. Then the fans would ramp up pretty severely, but that has never happened in normal operation. I think that's a much better way to go than to try to base it off the CPU temperature, because the CPU temperature is going to be influenced by, it's dependent on the water temperature and like how efficiently you can get heat from the CPU into the water. But the fans, turning up the fan speed only affects the water temperature, it doesn't affect the transfer efficiency. So essentially if my CPU starts getting hotter than it used to, I want to know about it and I've got an alarm for that, but I don't want my fans to ramp up when that happens, because it doesn't help particularly. They only make about, between the speed I run them at and full speed, there's only about half a degree Kelvin of difference to the water temperature, and that's not enough to materially affect the CPU temperature if it's gone high. So if the CPU temperature's gone high, what I have to do is repaste the block basically, because that's what's going wrong here, not anything that increasing fan speed could help with. So that's the rationale there, and then the same with the idea with the GPU temperature, because that's the other thing. I have workloads that stress the CPU to 100% and sit there for days, and I have the same with GPU, and so which of those things would I base the fan curve off of if I was going to pick one? I'd have to have a switch which is in charge from time to time, but by making it based off the water temperature, I don't have to make that choice, and I get the right behaviour all the time. So what else do I want to talk about? I want to talk about these RAM coolers. Without these, I can't run my system stably with XMP on, and with them it does work. So I don't know if they're actually cooling the RAM or if it's some other component on the board around here that needs airflow. Because obviously with the full water block, there's no airflow there, and anything that's not got the water block on top of it is getting much less cooling than it would do if there was an air cooler on the CPU. But so I can't say exactly why that works, but I suspect it is cooling the RAM, and I suspect I could get rid of them and make it stable by spending a bunch of time tuning the voltage on the memory to reduce it and stop the chips getting so hot in the first place. But that's I'd rather spend $10 on RAM fans than a day on messing around with that. You might be wondering why I am not using the DIMM2. So this bit's just for ASUS. If you're going to do this DIMM2, you need to angle these power connectors so that they come in this way, so I can get to both sides of them with the DIMM2 still installed. Because it's turned out with draining and refilling the loop that I've done, I do that more often than I mess with my M2 drives, and I can't get these connectors in and out with the M2 installed because there's just physically not space. So you either need to make a proper SSI board and space that out a little bit more, or angle the connectors at 90 degrees, please. For the water cooling folks, that will help us. Okay, let's talk about front panels. So I had to make my own front panel, which you've seen on the other side of the machine. What I'd really prefer, and I think would be good for the industry to think about, is if the case companies and motherboard manufacturers can get together and agree a physical spec for the front panel, like how big of a hole in the case will be allocated for a front panel, and then the front panel stuff comes with the motherboard rather than coming with the case. That I think would be an improvement to the industry. And the reason is, at the moment, if you're making a case, you've got to decide how many USB ports are going on there, which type of USB ports they are, and all of that. And if you're by a creator-oriented motherboard like this one, I've got, I can have two USB 3 type A's, two USB 3 type C's. I've got a bunch of USB 2 headers as well. I would like all of those on the front panel because I have that much USB junk to plug in that I have exhausted the ports on this board. But if I bought a cheaper board, I wouldn't have anywhere near so many. So at the moment, the case manufacturers have an impossible choice, or they're being forced to segment their cases based on like how much I/O you think you're going to have on the motherboard. And it seems also a bit environmentally irresponsible because, in a couple of years' time, I'm kind of expecting that everything on the front panel will be USB-C, and a lot of current cases will be, obsolete or have the wrong kind of ports on them. And it would be nice if, instead of the case having made that choice, it was just left. It was a part that came with the motherboard that you've got that plugs in. And it would, it would allow. I think you could do it like as a motherboard manufacturer. You could choose to go with actually we're not going to have a separate creator motherboard and a cheap motherboard. We're just going to make the one motherboard SKU. There's going to be 8 lanes go to the front panel, and if you want to buy the cheap front panel kit, you're going to get a couple of USB Type A ports, a USB-C, and your power on and off switch and your basic audio. And if you want to buy the creator front panel kit, much more expensive, but it's going to have, on the front panel unit will be a high quality audio DAC and amplifier, and then high quality ADC for your microphone. There'll be much more USB ports. There'll be perhaps a little, one of these little panels on the outside of the case will be more useful than on the inside. And a gamer's front panel with whatever the difference is, probably the same as the cheapo one, but in red and black. So anyway, and in that way, you'd actually reduce the number of SKUs that everyone needs to make. The cases wouldn't be obsoleted by a minor change in motherboard specifications. Motherboards wouldn't be obsoleted by a minor change in case specifications. It could be, I think, good for everyone. Oh, the other thing is, like, I just suspect that case manufacturers aren't super keen on the BOM cost of front panels, and a lot of front panels are going to be made with really cheap wiring, and so that's why you get this current industry, advice to always use your rear panel USBs if you're using. It's in so many device manuals. I think if the front panel came with the motherboard and was the same quality, therefore, as what's on the back panel, you could have a much more convenient experience as a consumer. I guess I could make the same argument about the rear panel I/O. It would be nice if that was a breakout that could be somewhere else, because I just don't like in conventional case. I'd like all of this to be down low and oriented here, but I can't do that with with any current motherboard, because there's just, I'd have to build a 13-inch wide, deep case for that to work, and I don't have that kind of space. If someone were to commercially make this category of case, they could do a lot better on the thickness than there's no need for this GPU to be sticking out. The thing is, between the front of the case and the back of the motherboard, I've got, it's 10mm of Delrin front panel, 20mm of extruded aluminium, then there's a 10mm thick motherboard tray, and I've got 8mm standoffs on that, which is again thicker than I need. I just needed to clear the bottom of the PCIe slot. That's why they're so thick. So if you were making this out of conventional sheet metal and so forth, you'd have room behind for cable management, which I don't have. Also, as you can tell, it wasn't a priority. But you'd have room behind for cable management, and you'd also have, this whole motherboard could easily be 20mm further towards the front of the case without having to do anything special. I said in another clip that the case I built doesn't really take up any more space on my desk than the original monitor stand, and so this footage is just to back that up. So it's the same desk, it's the same Gamers Nexus desk pad, but this is the original monitor stand with the back foot right up against the edge of the desk, same as the PC case is right up against the rear edge of the desk, and as you can see, it's pretty much occupying the equivalent volume. I mean, obviously you can place things on the desk in that around the legs. Thank you for watching. I want to express at this point my thanks to Gamers Nexus channel. Thanks Steve, thanks Patrick. Your case reviews were very helpful. I mean, you and I don't look for exactly the same things, but I appreciate your coverage and talking about what's important to you and why you feel it's important. That did inform my design. As you've seen, I didn't spend any time really on cable management. I decided it didn't matter to me for this case, but there are many other things like the focus on airflow and the work you've done to show how that works in some cases and doesn't in others. That was very informative, and it helped me with the design of the case. I don't know whether I succeeded or not, because I don't have the tooling to measure it, but it was in my mind when I was drawing the parts. Thank you also to Jay of Jay's 2 Cents. I enjoy your case reviews as well. I also particularly learned from your guide on how to water cool a system, because when it became apparent I had to do that. It was my first time. I needed to know what to do. So thank you for that. And although, as you've seen, what I used was black tubing and the most basic fittings and techniques to get it together, your videos on hardline tubing, coloured coolants, all of that stuff were very valuable to me in making it clear to me that I wasn't prepared to go to that amount of effort to make a system that looks good, and helping me make that decision was very valuable. And then thank you also to Roman of Der Bauer. I've been watching your channel since it was German with English subtitles, and now you've got the English channel. I greatly value your content. Again, helpful to me to know what I don't want to do because it's too much effort for my personal tolerance. But I have used a lot of information from your videos in tuning the system to how I want it, and in understanding, how the thermal changes I can make affect things. Obviously, I'm going for high clock speeds all the time, and not a peak clock speed for the period of time for benchmarking. But the techniques are, there's a lot of overlap. Anyway, thank you, Roman. And finally, I do want to mention Linus Tech Tips channel. They'd stopped doing case reviews before I started doing this, but I want to thank Alex and Linus for their stupid projects that they've done, because showing that you can kind of bodge together a system after it's gone a bit badly wrong on your CNC, or your design doesn't work exactly how you'd hoped, that kind of stuff, and was valuable to me in taking the scariness out of doing this project, because without that, I think all you see is these like nearly perfect industrial designed PC cases, and there's no way you can get from nowhere to that level, but you can get from nowhere to a basic prototype, to a second prototype, and then decide where you go from there. Third prototype if you need it, whatever. And so, yeah, again, thank you, Alex, particularly for showing the not immediate successes. Let's phrase it that way. Yeah. Finally, I know at the end of videos on YouTube, one's meant to say like, comment, subscribe. I'm going to assume you know how to use YouTube. There's not any point subscribing to this channel. It's not likely I'm going to do a follow-up on the same kind of topic. And yeah, this isn't the kind of operation that has subscribers, or I'm chasing gold plaques or whatever. So, do what you want. If you've watched this far, you have amazing patience. Thank you. I apologise for the quality of the editing and filming. I'm having to do this on a laptop and filmed on my phone because we're moving house, which was finally what forced me to film it, because up till then I didn't really want to take the computer apart, and then because we're moving, it could get lost or destroyed or damaged in shipping. So this was the last chance I could have to definitely film this PC case and show it how it's intended to work. So again, thank you for watching if you've got this far, and yeah, enjoy the rest of your day. This is the first prototype case that I made for the behind the monitor concept. I've put it on this work surface I have in the garage to show you that it's pretty similar in terms of depth to the final one. It's very... I want to talk a bit about prototyping and the nature of it, and expectations if you're interested in doing something like this for yourself. I think it's valuable for me to show you basically how crummy this is. So this was made entirely with hand tools. That panel outlet was cut with a jigsaw. This is just a bit of a rack mount panel insert that I glued onto there. So this is where my USB ports and network ports were put in with just panel insert jacks. This is my power supply holder, as you can see, held in with only 2 screws, and that's bits of angle iron that are just wanged in there and pushed around until they lined up with the power supply holes. The top of this case, don't know if you can see here, I discovered a clearance issue. I don't remember exactly what the clearance problem was, but I needed to lift the top up by 3mm. So it's just shimmed all the way around with bits of scrap wood to clear whatever it was that I had a problem with. Yeah, and then so that this prototype was intended to be air cooling. So this side was 4 intake fans. The airflow intent was air comes in, passes over the CPU here, GPU would be down here somewhere, and then is exhausted by 3 exhaust fans, and the power supply exhaust fan would have been inside the case facing up. So trying to roughly balance at least the number of fans to get a relatively neutral pressure. Yeah, I can't show you what the back panel looked like because it was just 2 sheets of 1/8 inch plywood, and I ended up using them for another project later on. The motherboard tray is the same piece of wood as the front panel. It's got these press fit inserts put into it, and some unshootable glue. Yeah. So what was this is RGB all the way around the case to illuminate the wall behind the computer, and then this piece is actually separate but designed to be fixed to the case. And so your front panel connections and not DVI, how old am I? DisplayPort came through these holes and through this corresponding slot at the bottom of that kind of tower there, and there was a front panel unit plugged on here. I've lost that or reused it for something else. And then the display connector connects to the display somewhere up there, relatively concealed from view. The display itself is mounted to this. This is half of one of the Visa mount adapters you saw on the previous on the second prototype. And so this was enough to let me test a lot of things. So I want to talk a bit about the process of prototyping. So I built the frame with with this top panel in its correct position and without the RGB. Installed the motherboard, the air cooler that would fit inside that case, the graphics card that would fit inside the case, all the fans, power supply, whatever. Booted it up, put it on my desk, had the monitor with the monitor attached. At that point I can test, like, is it even physically possible to assemble a machine in that kind of volume, and do I get the what about the experience? Do I like, what do I not like? And so I got to that point, and I could sit in front of the computer and see what I was going to see. And one of the things I decided was I really didn't like having the case visible above the monitor. So I could see about this much above the screen, and I didn't like that. So from that point on, I'm already thinking, okay, the next prototype will try and make it shorter so that it doesn't protrude above the top of the screen. But that's not the last thing you can learn from this prototype. So once it's all built up and air cooler installed and everything, ran some benchmarks of software I really intend to use. So I do some CAD work, for example, which is a pretty similar workload to Blender. The CAD program I use isn't very easy to benchmark, but Blender's cycles renderer, which is very on the CPU, is a very similar workload to the CAD software's renderer. So I thought I'll just try that. Ran that, and what I discovered is I was getting throttling on this CPU on air at any kind of tolerable noise level. So I did some ad hoc checks to try and verify that the airflow was doing what I imagined it was inside the case. That all looked fine, but I was not getting I couldn't get the CPU temperatures under control to give me the performance I wanted and that the system is capable of in in better conditions. So that was when I thought, okay, let's do water cooling on this thing. So I'm pretty. It's a while ago, but I think I ended up shimming the top here in order to give myself clearance for the radiator inlets at this side of the case, and so that I could test with a 560 radiator on this side, and that did let me solve the CPU cooling issue, and from my measurements it seemed like there was loads of thermal capacity left, so water cooling the GPU would also be fine. Well, I think pretty trivially, if you've got all your intake going through the radiator and an air-cooled GPU is fine, it will not get worse if you also add the water-cooled GPU to the water loop. So yeah, so that's how far this prototype could take me, and by the point I kind of retired this prototype, I'd found out that illuminating the wall around the back of the system was a good idea, but doing it attached to the case didn't give you the right kind of angles. I'd either have to build some kind of wedge into the... That's why this one's taped. I had an angle system going on here for a while, so I could check what angle I needed the lights to be at. It turned out that the angle that was on the monitor back panel was already perfect, so that's why the newer version of the case had the lighting there. I found out that I didn't like seeing the top of the case above the monitor, and so I wanted to lower the total height. Obviously I knew because of measurements I could go wider originally. This is the size it is also in part because that's the size of wood panels you can easily buy in. So it's 24 inches by 12 inch. Nominal paneling is mostly what this one was made of. Yeah. The other thing I'd found out was this bit of the case underneath the screen got very dark, and I can't show it here, but I had prototyped putting some LEDs on the bottom of the monitor, and that sorted it out. So that's why prototype case 2, which is the one you've seen primarily in this video so far, has the features that it has. Case 2's not been... What you're seeing as case 2 is sort of the end game of it. It did start slightly differently, but the changes are mostly internal or to materials. So the Delrin parts were originally made of acrylic, but I didn't like the fragility of acrylic for some of those parts. So that's why the motherboard tray I remachined in Delrin, and in the case of the front panel I had spare Delrin, and I thought it would look prettier than the acrylic I had on that area, so that's why it got changed. But yeah, I guess what I'm saying here is more about prototyping than about cases, but the idea of prototyping is to learn as much as you can from a given prototype, and then once you hit you can't do the next experiment, or you like the final thing has to be very different to this. That's when you build the next prototype, and then you adapt that for a while until you know what you want to do. And in my case, my adapted prototype 2 is at the limit of what I can do. Like, it's as good as a case I can make, and so the next thing for me to do is either start up a case manufacturing company and invest hundreds of thousands of dollars in tooling and make a nice case out of sheet metal, or make this kind of video and try and persuade a existing case manufacturer to do something where I can have a monitor attached to the front panel of my workstation. Anyway, if you've watched this whole video, thank you. Sorry it's so long.